Hey everyone, welcome to the Hasura community call. If this is your first time joining our community call, I am Vish and I work on the developer team at Hasura. I'll be your host today. We do these community calls every month where our engineering team talks about upcoming features, gives product updates, and we also demo some cool new features um, that are coming up. So, yeah, thank you so much for joining. And quick look at the agenda. So, Tiru will be kicking this off. Let's see if Tiru is here. Hey, Tiru, if you're here, just give me an ACK and we can start this off without further ado. Let me stop sharing my screen and see if Tiru is here. Okay, while we wait for Tiru, I'll share my screen again and tell you briefly about today's agenda, which is super exciting. So Tiru will be firstly talking about multiple databases in one query, followed by remote schema permissions. And since Tiru is on fire today, he'll also be demoing Postgres volatile functions as mutations. Gavin will also talk about a community project, which is super interesting. Tanmai will be giving a really cool intro to that project later on, which is called Data Dictionary. And Shahidh will be talking about GraphQL observability with Hasura. Now we always like to welcome community presenters at our community call, and this time, luckily, we have two of them. So it's going to be a really amazing time. So our first presenter is Bostjan, and Joseph from KintoHub will also be doing their community demo today. So yeah, let's see if Tiru is here.
Hey Vish, if there isn't, then we can do I can introduce the data dictionary, Gavin, and I can start with the data dictionary. Does that sound good?
Perfect. Let's do that.
All right, let me share my video and say hi. Hey everybody, and let me switch on my cool virtual background so that it seems like I'm more outdoorsy than I am. This is feels like I'm in a garden. So let me just quickly bring up my screen for a second.
Hello.
Hey Tiru. I got started with the data dictionary, so I'll do that, and then you can go on with the.
Yes.
All right, that's awesome, cool. Okay, so can you folks see my screen on the presentation mode thing? Yes.
Yep.
All right, thank you. Cool. Right. So, all right. So, over the last few weeks, we've been working on what we call the Hasura Data Dictionary, which is a set of components that will help you kind of build your own data dictionary. Right. So, let me talk about that in what that means in a bit. So, the kind of problem or the goal is that what we want to do is anybody who's consuming a Hasura powered API, we want to make it easy for them to understand the various models that they have and the methods that are available on those models, right? I guess that's every single API that you're using, right? That's what you want to do. So you want to see that these are the various entities that I have, and then these are the queries and the mutations and the subscriptions that I can do on those entities. And that's the reason why GraphQL itself is so popular, because GraphQL makes it really easy to understand what those operations are and what those entities are. From a Hasura point of view, what we want to do is when we think about these methods or the operations that are available on these models, right? You from a GraphQL operation point of view, their queries, mutations, and subscriptions. And from a Hasura point of view, they could be coming in from your database back methods directly, right? Like you fetch by a single element, you fetch a list, you fetch aggregates, or it could come in from remote schemas where you have a remote schema that is referencing a particular element or vice versa, right? And so that becomes essentially a method that operates on or references that model that you have, or an action, right? Where you're saying create user, which does something and then ultimately returns a reference to a user, right? And so those are examples of like the things that the various kinds of operations that you can have on the model. The reason why this becomes, or this is important, is, and why a model first view rather than a method first view, which is if you look at a GraphQL API and the result of a GraphQL API, you would see all of the methods that are available as queries, right? And the reason why a model-based view becomes more important sometimes is because when you have hundreds or thousands of tables, and as we've been working with some of our users, and they have a really large number of existing models, right? It becomes very tedious to look at the entire API in one shot, right? And you need kind of a more gradual model or a semantic way of kind of approaching or navigating this landscape of things that you have. And so that was kind of the precursor or the reason why this effort started coming together. Now, the first question that you might have is, why isn't the GraphQL API introspection result enough, right? And that isn't enough because the GraphQL API might expose way too many methods that get in the way of understanding these models, right? So again, like you might have fetch a list, fetch an aggregate, fetch a single user, run a custom action, run a remote schema that references this, a different GraphQL resolver or API or a root field that references this model, right? There's a lot happening, and you don't necessarily want to get into all of that before you first understand what this model is, right? Imagine if someone new getting into an API or getting into a project that has thousands of these kinds of models and like 5,000 methods on those models, right? In that regard, it must be said that there is something to go for. When you think about like a REST API, right, and idiomatic REST API that's organized well, it is sometimes easier to drill down into the things that you want, right? Because it could be more model based. If you look at, like, for example, the Kubernetes API documentation, it's quite nice to kind of look at a particular, like, oh, here's a deployment entity, and these are the various things I can do to a deployment, right? It's convenient because you can map your understanding of Kubernetes to the API quite easily. The other kind of information that you need from the APIs and the models is something that might be is information about the model itself, which might not be available in the GraphQL introspection result, right? For example, you want to see which fields are actually columns, which are indexes, right? Where do these fields come from? Is there like a lineage, some information about a lineage that needs to be embedded into these fields, right? And then if you're looking at it from a particular role point of view, maybe you also want to expose information about what permissions in Hasura can also have comments, right? So you want to have like a comment that describes who has access to these entities, right? And so you need a little more information about this model. You want to surface more information about this model, which can't go into the GraphQL introspection API itself, because that piece is kind of information that is a little more to do with the server that is implementing the API or the data source itself, right? The third piece of information, which I think is the most important, especially for large kind of schemas, and what we've seen is that if you want to associate more structured content and meta information about these models, you can't capture them in the GraphQL comments, right? Imagine, for example, that you want to have documentation for every field that is if it's multilingual content, or you want to internationalize it, right? You want to have documentation for what this particular field is in different languages. Now, how will you capture that inside a GraphQL fields comment, right? It's not enough to just provide like a text string comment. It has to be a little more structured if you want to capture that. Even when you view the schema documentation, you need that content to be viewed, right? Or maybe you want to have like a sample query associated with the model that you want to show users and tell users, hey, you know what, why don't you copy paste this query and get started with this query, so that it gives you a meaningful result. Or suppose you need kind of more information with it, like images that are associated with a particular field that you might need. So suddenly you realize that you kind of almost want like a metadata CMS type thing alongside your API documentation that is closely linked to your API that needs to exist, right? And the GraphQL introspection result itself cannot natively power these things, right? And so the kind of solution that we've come up with that Gavin will preview today, it's still it's not completely done, but the building blocks are emerging, and those building blocks are basically two. The first building block is a API, and it's a GraphQL API that serves the Hasura metadata and the data source information. So it's an API that you can add that will tell you everything about the data as it is in, say, Postgres, and all of the information in that database as well. This is a key, this is a constraint, this is an index, this is a primary key, right? And here's the Hasura metadata associated with it as well. Or you start with the Hasura metadata and then kind of go into tables, right? So you say, here's the Hasura model, which actually comes from this Postgres table and this remote schema. And then these are the fields that map these database columns, and this is the documentation associated with it. So you have a GraphQL API to fetch that information. Today Hasura already exposes these APIs, but these APIs are available only in kind of a privileged way, and it's not a GraphQL API. So the first thing is a GraphQL API that gives you this information. The second important piece here is that it's actually role-based. So that means that when you make a request for fetching this information, you can actually pass in a role and get the right slice of metadata and data source information for that particular role, which makes it very convenient, so that you can kind of have a view of this information for a particular role, right? And that's nice. The second piece of this data dictionary solution is a set of React components that use the APIs and provide certain features, like for example a search feature. So we take this metadata and data source information, we index it locally on offline storage, and then you have a nice kind of convenient quick search feature. You have a model view, you have methods available on that model, a visualization method that is a little less intense than like a full GraphQL schema visualization, which would be like a lot, but kind of a more condensed visualization that can then give you more detail, right? And those are kind of the two building blocks to this solution. The three killer things about this that I really love, and that we designed, that we had in mind when we designed this, right, is that this GraphQL API can be added to your, so this is not today a part of Hasura, right? It's not a part of what Hasura by itself gives you. It's a separate GraphQL API, kind of like a serverless function that you can run and deploy, and that you can add to your Hasura project as a remote schema. So by default, your Hasura project will not have this kind of what we call the HDD or the data dictionary API. This API has to be added as an extra remote schema. The advantage of that is that it can be protected by a role. So, this, because the data dictionary API might be privileged, right? It might not be something that you want to give to everybody, right? It might be something that you want to give to certain developers only, or to certain types of people, and you can now protect it with the role, which is a little bit meta, right? Because you're like, wait, it's metaception, whatever the word here is. And then the third aspect of this is that you can also add in another data source, like a Postgres database that is exclusively like a CMS for your API. Or you can use maybe something like Contentful or an external CMS altogether that has more documentation or structured information about your fields, right? So you can say, hey, here's the field, here's an image with it, here are the 5 different languages in which this is documented, and now that can be managed separately, right? And the nice thing is you can join between this GraphQL API and this information schema that you have, right? This extra information that you maintain. And so that way you can keep extending both the GraphQL schema itself, like the introspection result, and the Hasura metadata associated with it, and the database information or the data source information associated with it. All of these can now be extended with custom attributes and extra information that you want, so that you can kind of create that perfect data dictionary API and portal that you need and that you want to have with your developers, right? With the right mixture of the React components that you have and the APIs that you have to set this up yourselves. So Gavin will be doing a demo, and this is not yet ready for launch, but this is something that we've been working on, that we wanted to show off to you folks and start a discussion round, and this should be very exciting. So Gavin, over to you for a quick demo.
Oh, I'm on mute still. Okay. Let me share my screen. And you guys can all see and hear.
Yep.
Yep.
Oh. Sorry, I tried to drag the the Zoom thing out of the way because it's blocking my bar. Okay, anyways. So yeah, this is essentially what the API looks like. So you have your Hasura metadata, which is just your metadata.json that you would get from your Hasura instance. And then here this says Postgres, but this could be other data sources in the future too. And you kind of have tables and views with columns, primary and foreign keys, indices, all that stuff. And so what this allows you to do, close this, is kind of get a really easy view of your data. So the first page is essentially an overview of all your data tables with a description and the source. You can kind of search here. And so let's say you want to know more about actors. You're like, okay, well, I want to see actors. These are my database fields with a description. You can see your indices here, as well as all the queries in your schema that are related to this, the operations. And then this down here is like a first and second degree relationship view. So let's say, okay, well, I want to know what information do I get back when I query this, and what does that query look like? So you can click try it out here, and it'll pre-fill this. Obviously, more work needs to be done, but let's assume we remove those fields. Then you get it here. This tab, this data graph, is a sort of ERD view of all your data models and the ways that they're connected. Again, not a final UI. So let's say I want to know what invoices. I can see this here, object and array relationships. And let's say I want to go to the detail page, and then that pops me back over here. Yeah, so that's pretty much what we got. Hopefully, people can build some cool stuff with this. It's all, Next.js, React, Tailwind. Yeah, so that's what I got.
Awesome. Thank you for the demo, Gavin. Next up, we have Tiru, if Tiru is ready.
Hey, folks. Hi. Can you hear me?
Yep.
Hey, sorry for the delay earlier. My Zoom did not work. I had some hope that it will work because it worked a little bit earlier, but it did not. So anyway, let me start sharing my screen. Can you see my screen, which is proxied via Google Meet?
Yes.
Okay, cool. So yeah, so I'm going to show 3 demos, and all of these are like features which are already in preview, and they're in separate PRs, but they'll be merged together and will be released in version 1.4. But we'll just see what these features are and what this enables you to do. So the first demo is doing just one GraphQL operation over different Postgres databases. And we saw in the last community call that now you can have like different you can add different Postgres databases, you can add MySQL database and so on. But what we'll see here is kind of like requesting data from these different data sources together in just one operation. So let's go to the first demo here. Quickly check that I don't have any Docker containers running. And this is my Docker Compose file. And I have 2 Postgres containers in this, Postgres 1 and Postgres 2, and I'm running this preview build. So let's start this. Cool, so let's see if it's running. Yep. And what I'm going to do is initialize some data in the first database and also initialize some data in the second database. So let me just do that using PSQL. So I'm creating a table called authors in the first Postgres database, and I'll create a table called articles in the other Postgres database. And just a contrived example, probably not the most semantically sensible distribution of data, but you can have any tables in different Postgres databases, right? So using PSQL, I'll populate the first database. So 1 second. Oops. So then restart mode. Let me check this. Let me just restart this and try again. Or, okay, let me just try this one more time. No. So what I'm going to do is quickly change this back to one database, and then we'll launch another database. Fingers crossed. Okay. Okay, so this seems to be stable. And I've also launched another Docker container with Postgres separately. So this is in, let's call this Postgres 2. Okay, a little bit of startup trouble, but yeah, so we have 3 containers here. Postgres 2, there's one Postgres, and we have the GraphQL engine running. I want to initialize the data here. So inserted the table for articles in Postgres 1, and I'm going to do the same thing, but on port 7432 for Postgres 2, right? So now I have data. So let me go to my console here. 3000. Cool. So if I go to data tab, I can see Postgres 1 author is available in the default Postgres database. So I'll quickly go and track that. And I can also kind of add another database. Let's call this Postgres pg2, and I need to give the connection string. So let me take that from here. Okay. And a small thing that I need to do is, since I'm connecting to Docker, I need to change this to the Docker port. Click Save. And now if I change the Postgres database, I can see that the articles table is here. So I can track that as well. And let me start querying, right? So I can query pg1 author. And this returns some data from the first Postgres database. And I can also do pg2 articles. It returns some content and ID. And we can see articles. And what I can also do is just do them together. And I can see that the data is returned from both databases and joined together. Not joined very deeply, like they're kind of like just concatenated together. But this is the kind of a feature that will enable you to like query from different data sources at the top level. It could be a remote schema, it could be MySQL and Postgres and so on and so forth. So that infrastructure is ready. And that was the first demo. So the second demo is, let me just tear this down meanwhile. Start by SV and start. The second demo is for remote schema permissions. And this is a huge feature where you can kind of have the Hasura authorization system for remote schemas as well. So if you're using remote schemas, you would know that there isn't any role-based remote schemas, or you don't kind of use any Hasura session variables and so on to do authorization over your remote schemas. They are all exposed to all the fields of your remote schemas and all the arguments and so on and so forth. Everything is kind of exposed at the top level. So we'll see kind of like how you can start enforcing permissions on your remote schemas as well. So here I have again my Docker Compose file. This is different PR, and let me just see. Can stop this actually, and let me start this application now. Cool, so that is running, and this also has some initialization data. So I have a users table here, and it has one row. So user has a name and an email and so on. So I'm just going to populate that. Use PSQL for this and init.sql, right? So if I come back, now I have a console running locally here. 1002, I guess. Right. So I can see my users table here, just going to track that. And sure, I can query and so on. But what I want to do in my application is kind of get their Auth0 profile also along with the users. And we know that you could do this using remote relationships. So I'm just going to use that and first add a remote schema, and then I'll create a remote relationship. So let's call this Auth0 schema. Let's add the URL for the remote schema and add the remote schema. Cool. So if I come here, I can query for users, ID, name, and email. But I don't have a Auth0 profile yet because I didn't create a remote relationship. Quickly go and create that from the relationships page. Let's call this Auth0 profile. And I can say join the email argument of the remote field with the email column of my table. And now I would be able to see Auth0 profile field, and I can say created at last login, user ID, so on. This is cool. We didn't need any extra permission layer over our remote schemas to kind of get kind of join the authorized users in the table with the remote schema. But what we also can do, if we see today what happens, is that the top level field which is exposed in the remote schema is also available for querying. So I could as well say email, and I could say Tiru at Hasura.io and get the same things here, last login and user ID. This is fine. But suppose I knew some other user, right? So Tanmai G at Hasura.io, I could kind of get their information also from the remote schema just by passing this argument. So what I need to do so that I only get my information is kind of hide this field altogether and get the Auth0 profile only through the remote relationship. And to do that, we will now start adding permissions to our remote schema and introducing remote schema permissions, which is shown in the console in the remote schema page as the permissions tab. The UI is minimal. It's work in progress. We have prepared something minimal for this community call. It will change, but this will get the idea across. So as usual, I'll create a new role. Admin has all the permissions. And if I edit the permission for this role, I see a GraphQL editor, right? So what this means is that you could basically give any schema of your, which is like a subset or which is like kind of like a slightly transformed version of your actual remote schema, so that it fits the role permission that you want to give, that you want to expose to the end user, right? For example, if I had the remote schema, and the remote schema is basically I've hosted it here on Glitch, so we'll see what the remote schema is. It's a very simple remote schema. This is basically the definition. We can see that it has just a hello field and an auth0 field, which is what we used. But what I'm going to do is hide the auth0 field from the top level for the user role. So I can just type query and say, I only want to give hello string and nothing else, right? So this is kind of like a subset of this schema. And you could say that for that role, the user role, the only schema that is available is just the hello field under query root, right? And I can save this permission. And if I come back to my graphical and try to run this query, it will run because I have not added a role. So let me just add the role as user. And if I run it again, I would see that auth0 field is no longer present, right? But if I kind of run the first query, which had the remote relationship inside the user's field, I would not see that because I have not added user's permission on this table. So let's quickly go and set that without any checks, toggle all, save. And if I run this now, I get my data as user role. I also get my auth0 profile, but I cannot get any other auth0 profile by going directly to the remote schema. So this is one very important use case where you want to kind of just show join data, which is already authorized by your table level authorization. And it kind of lets you kind of use the remote schema only for the things that you want to kind of expose in your API. The second thing that we can also see here is, suppose I want to expose the remote schema, but for a different use case. I want to kind of have Hasura as a GraphQL gateway. I want to bring in a lot of remote sources. And I don't really have remote joins, but I want to kind of enforce some constraints like if I have, say, a user ID, then you can only get the user ID from your remote source as well. So to show that as an example, I will create a role called auth0 now. And what I'm going to do is copy this schema here. And I'm going to modify that. And the way that I'm going to do that is kind of restrict the arguments that you can kind of expose in the graph. So I'm going to remove auth0 ID completely so that the auth0 role can only query via email. And the second thing that I want to also do is I want to set a preset for this. And the preset is basically coming from a session variable. So you can say Hasura user ID, right? So this is kind of the graph that we want to expose to the auth0 role. You have the auth0 field with fewer arguments. And also the email field has a preset, which is Hasura user ID, right? To make it more semantically meaningful, let's call it Hasura email, right? And the rest of the graph is here. You could kind of hide the fields from this type if you wanted. If you didn't want to show kind of like the picture or something, you could do that as well. So we have created the auth0 role now. And if I just change this to auth0 role and start querying again, I can see auth0, but I won't see any, so I can't see any arguments here. For example, if I open export Explorer, I can't see any arguments that I can give here. That's because there was only one argument called email, and that also has been preset. And let me just get the usual things: user ID, email ID, last login, and so on. And if I run this, this would throw an error, which is saying that Hasura email was expected. So let me just give that. And now you can see that without even providing any argument, we are getting the data just for the Hasura email that is coming from the session variables. So this is the second powerful part of remote schema permissions. The first thing was that you could kind of hide all the fields and only show a subset of the remote schema graph. And the second part is that you can add constraints via presets like Hasura, which can use Hasura variables, which can use static values and so on. It can have complicated input object types where some fields of the input object type are kind of preset, some other fields are not. So you can query it from the client, but at runtime, the other fields would be injected with the session variable and so on. So that's basically remote schema permissions. Allows you to kind of add lots of remote schemas and then do role-based schemas on that. Yes, so this was the demo. Now we'll head to the final demo. Let me just start that here. Okay, so let me tear down this environment, down -v, and go to volatile functions. So the final demo here is going to be that now you can add Postgres volatile functions under mutations, right? So volatile functions in Postgres are basically functions in which you can do insert, update, delete, and so on. These are not allowed if you have a stable function or an immutable function, and hence Hasura was supporting stable functions, immutable functions under queries because they are read-only. But now you can also add volatile functions under mutations, and this means that you can do all kinds of business logic in your Postgres database. Use stored procs if that's lots of use cases where you can do business logic before writes, right? So let's start the environment here. Docker compose up. Okay, so I have container running. I want to show you what we are going to do. We are going to create an article table here. Again, let's use PSQL to initialize that. And let me go to the console now. So that's in 3003. So, sure, second. Oops, 3002. Right. So I can track the article table. And what I want to do is kind of have my own insert for the article. I want to call it add article. And it's going to do some business logic like checking the length of the article which is inserted before. And if it's satisfies, then the insert goes through, otherwise raises an error. Kind of like a small validation use case. So let's see what our function is for adding this article. There's a lot of boilerplate in creating a function in Postgres, but I think the important bits are that we are kind of checking the length of the content, which is an argument, and we are also taking author ID as another argument. So basically, you can add article for an author ID with some content, and we do a length check here. So I'm going to track this. I can see add article is, so I didn't track it in the run SQL, I'll track it from here. Previously, if you were kind of looking at this page, and if you had a function like that, which is doing insert, which is like a volatile function, you wouldn't even see that in this list because volatile functions are not supported. But now you can do that, and I'm going to click track. So this is tracked, which means that I can come here and I can see under mutation, I'll have an add article field, which takes an argument, which takes few arguments. So I can give author ID, and I can give content. Say this is some large content, right? And then I can get the data back with whatever is inserted. And this will kind of throw an error that article is too large. I'm an admin, I see a lot of errors, but yeah, essentially you'll see an error like this. So if I just change it to something smaller. Here you go. So this goes through, right? So I added a top level field under mutation, which is kind of running a Postgres function. So this was the essence of it. But now you would be wondering, like, what is the permission system here? Because you might want to add more role-based logic and use session variables and so on to like do more authorized business logic in your functions as well. So I will show you how that is done by adding another function, which kind of accepts the Hasura session variables. And this is similar to how stable functions also work. You can kind of give Hasura session variables as an argument and run your own business logic with the session variables that you have in your custom function. So let's call it add article. Let's just call it add article 2. So I can see that there's an extra argument here called Hasura session. And what I am basically doing with Hasura session is that I'm injecting the Hasura user ID from the Hasura session variable here. So no matter what insert you do, the author ID is always going to come from the Hasura session variable, right? So this is basically the business logic there. And come back, get a track, and let me add article 2 here. And so let me remove author ID. Oh, it doesn't have a default. So let me give an author ID here, but let's see what happens, right? Content. Again, let me just reload this. So okay. So the error kind of suggested what I was doing wrong. I have not actually modified this to actually set what my session argument is, right? So if you look at the function, I have a way to say that this argument, which can be arbitrary, is actually going to be populated by my Hasura session variables that are passed from the authentication system, right? So now if I come back here and run this, I would see that author ID is null because I didn't pass an Hasura user ID. And if I pass that as say 10, so yeah, even though I'm passing author ID here as 1, the final input is going to be 10. I can also remove that and insert content 2. And this kind of, okay, so there's a slight issue here where you have to set default arguments if you're not providing all the arguments here, which can be done at the Postgres layer, or Hasura can hide it automatically, make it like optional. But yeah, so the essence of it is that you can kind of give any value like 200, and because of the way that you have set the way that you're using the Hasura session variables, you can get the actual author ID to be set from the session variables. So this was custom functions under mutations. So if you have like Postgres volatile functions, you can add them now. You can use Hasura session variables there to write your own authorization logic. If you have any custom authorization logic, you can use that there. And this also, so another thing about this is that although we have returned the article table, it's also using the select permission system of your article table to give you the final result. So it gels well with the table permissions that you might have already set on the article table. And you can do business logic of writing things inside the function, but the final set that is returned will apply the select permissions on your table also. And that is what is expected when you have a table return type, and that's what Hasura will also do. So that's it from me. So 3 demos. If you have any questions, happy to answer them on chat. Over to you, Vish. Thank you.
Awesome. Thank you so much, Tiru. That was an amazing set of demos. As Tiru said, if you have any questions, him and rest of the presenters from the team will be hanging out in the chat. So feel free to ask them in the chat. Next, we have Shahidh to present GraphQL Observability with Hasura. Over to you, Shahidh.
Thank you, Vish. Hi, folks. I'm Shahidh. I work on Hasura Cloud. I'm going to show you a sneak peek into some of the Hasura Cloud features that will help you get GraphQL observability. We're going to look at some features that already exist, as well as a few features that are in the pipeline. So we already have some observability features built into Hasura Cloud. We can use the Hasura Cloud Console and look at the operations tab to monitor what operations are happening on the API. We can analyze what kind of errors are happening. We can use it to visualize traces, and I will show you a demo of the feature that we've been working on, where you can configure your Datadog API key on the console, and then you can export the data, all the operations into Datadog. So I have a Hasura app here, and I'm going to make a GraphQL query now. And this is a table in my Postgres instance. It just lists out, so the table that I have, if I go here, it just lists out country codes for a few countries. So I only have the codes here, and what I have done is I have a remote schema where uh, where I am using a GraphQL API, which is this countries or travel blades, and I will use the code and expand the details from the remote schema. So what I want to show here is when you execute this GraphQL query, you get the response from Postgres. So if I look at my operations tab in under the monitoring section, I get to see that this operation was made a few seconds ago. And if I inspect it, I see that I get a timing graph here. So the GraphQL query was executed and it took so much time, which 96% of the time was spent in querying Postgres. And now if I change this to include a remote relationship to also fetch a name and capital of the country based on the code, and when I do that and I get the results back, and if I look at my uh, operations tab again, I will see that there is one more new operation, which is get countries with remote. And it's going to tell me that GraphQL query was made, and a query was made to Postgres using this particular GraphQL endpoint, which is my remote schema. So if you look at this, huge chunk of the time was spent in querying the remote schema, and it responded with so much bytes in the body. So this is the tracing feature that Hasura gives you, and the data is visualized on the Hasura console itself. You also get to see the operation string and the request headers and various other parameters about the request, including the execution time and and the response size and all. Now, let's say when somebody made your application was deployed with some kind of an error. So, for example, a GraphQL query was written like this with name here in the at the root of the table, uh, which is supposed to come from the remote relationship, right? So if this particular operation was deployed, and if this error kept happening on your API, you can again use the uh, tabs available here to track those particular errors. For example, if you go to the error screen, uh, it takes bit of time to load up. So if you go here, you can see that in the operation screen, the error is already tracked. So a few seconds ago, countries with name was executed, but it was an error. So if we inspect the request again, we can see that the error message is validation failed and field name not found in the type my countries table. So the GraphQL operation is also shown here along with the request ID. And this data is aggregated and shown as a separate error in a separate error page, where it says that this operation happened 3 times and it resulted in an error. And you can track all the individual operations from that particular screen. And now all of this data can be exported to Datadog, and that's what we're working on. It's a feature that's going to be launched soon. You'll soon be able to enter your Datadog API key in the Hasura Cloud dashboard, and that will integrate with Datadog by sending all this data into Datadog, into your Datadog account, where you can track the traces and everything with your existing services. So the table is created, and we are making a query into that table. So we are getting, say, ID and name, and some data is sent in response. And we can, at the same time, if we have Datadog open on live tail, we can see that the data is going to appear now. The operation data is going to appear on Datadog. So we're just going to refresh Datadog, and we can see that the particular operation has appeared here here on the Datadog log tail. So you can see all details that were shown on Hasura console is shown here as well, with separate very well formatted structured data. And you'll be able to create alerts or filters, or you'll be able to set up dashboards based on the metrics like execution time here. And you'll be able to set up much more visualization and also correlate with data coming into your own Datadog account from your services. So this feature should be available soon on Hasura Cloud. That's pretty much it from me. Thanks a lot. Oh, back to you, Vish.
Awesome. Thanks so much, Shahid. We'll now be moving forward with the community demo section. Let me call on Bostjan with his demo on digitalizing planning poker scrum with Hasura. Over to you, Bostjan.
Yeah, so hi everybody. First, I'll just issue an apology to anybody who's expecting another more in-depth technical insight. This time it's going to be a bit different. And I'll be presenting how we actually are trying to use Hasura to empower MVPs. And also, as always, I can see that the Hasura team is actually adding features faster than I can actually try them out. So good job, guys. I'm going to be sharing my presentation now. So, okay, for those of you who don't know what planning poker actually is, it's Scrum is an agile method for developing software, and basically every 2 weeks you have a planning phase or more depending on your cycle. And that's a time when the team basically gathers and they try to give a rough estimation on their tasks. And this is what the game looks like in real life. So you have a deck of cards, the developers throw those cards on the table, and they basically try to make those estimates the same in the end. And yeah, so naturally with the lockdowns, hoping that everybody is safe, we wanted to do this planning online. And existing apps were actually too complicated for our needs. Either you needed to input a lot of data to start the game, or they were full of features we didn't actually need, or they were super expensive. We actually decided to build our own. And we decided to use Hasura and actually track the time that was needed for the development of this app from start till the end of the process, and actually compare that to existing estimates that the other teams at our company gave out to actually show that Hasura actually makes development a lot faster. And yeah, so sort of just to give you a bit of background how this process went, and if anybody is bored, they can actually also listen to the songs that are written at the top of this presentation. So a few pictures that happened during development. So, you know, the planning stages when you do a paper prototype of how things are supposed to look like. And then communication, basically, this is lacking at its finest. My colleague was doing the mockups for the front end, and also the final designs, and to move on to things that are more interesting to the technical savvy people out there. The stack that we were actually using, so React plus Hasura plus Caprover for our infrastructuring needs. And I'm guessing that this is another abbreviation, RHC, that maybe it will catch up, maybe it won't, we'll see. And so the agreement actually was, so there were two teammates working on this, and I do the back end and my colleague does the front end. And for those of you out there that don't know the power of Hasura, I was basically in a better position because naturally backend development was a lot faster with Hasura. And if there are any front-end developers out there or full stack developers that are trying to do the same deals out there, make sure you say no. So we all know that actually Hasura is filled with a lot of magical features that were presented during all of the previous community calls. I think that one that is actually very underexposed is the feature for running cron jobs. So you can imagine that in this app, we have a lot of games running simultaneously. The games are only valid for 8 hours, and then we basically don't need that data anymore. So for us, the golden feature was actually this cron feature that we used to actually delete our old games. So if anyone hasn't used this feature before, it's in the event section in the cron triggers tab, where you can actually build your cron tasks that are triggered on a basis that you define. So this was actually a very useful thing for us, which basically needs no time to set up. You only need your logic that does whatever the cron job does. And yeah, moving back. So here's a Yoda quote: repeat yourself many times you do. That's our cron job. And just to give you a little bit of insight on how this looks like, if anybody is interested into a more in-depth analysis of how we used less time with Hasura, the magical number is we've spent like 85% less time based on the estimates that the other teams did for developing the backend logic. And we kind of used that time to focus more on testing the features and also doing the front end. So yeah, it's really a thing that we are now trying to use with our other clients as well, and prospective businesses out there that have ideas and want to basically push those ideas in real life. We think that Hasura is actually a real empowering tool to use in MVPs. And yeah, so that I won't be just talking, if you want to use the app, it's located at this URL address, plan-poker.app. And I'm just going to show it to you right now how it looks like. So basically simple. You create a room as the administrator, you pick your name, and then you throw the cards on board. If you want to share the link, you just click on this and share the link with your other teammates, and that's basically it. So we see a lot of people are using it right now because it's really simple, and also we are using it as a technical demo for our other clients too, so that we can show that Hasura really is a powerhouse, sort of speak. And yeah, naturally, there are pull requests available. If you want to add anything to this, the whole thing is open source. You can find the link on the app page. And my final words would just be graph on and make sure you add something to the community as well, because we really want to return something back, because we've been using Hasura for a while now. And just to give you a bit of heads up, we are building something internally that we think will be really useful to empower Hasura even more, but maybe that's going to be presented in another community demo. So that's it from my end.
Awesome. Thank you so much, Bostjan. That was a really cool presentation. Love the songs. Now we have Joseph from KintoHub with his presentation on deploying Hasura on KintoHub in minutes. Over to you, Joseph.
Hey, thanks. Could you guys see my screen all right?
Yep.
Cool. All right. So KintoHub is a platform that just makes it easy to deploy apps into the cloud. We've been huge fans of Hasura for a long time and actually used Hasura to build a beta version of KintoHub back in the day. So what I'm going to do quickly is just show you guys how you can deploy the open source version of Hasura alongside a Postgres database on KintoHub. So here's an example environment. When you create an environment on our platform, you can just go here, choose a region. It could be North America, Europe, or Asia. Here I'm in Asia, actually out of Hong Kong right now. At the top right, you can create a service. And the first thing we're going to do is create a Postgres service from our catalog. So there's Postgres there. I'm go ahead and put in the username, password, and hit deploy. So here it's going to start deploying the new database. This takes about a minute, and this is a dedicated database. It's not shared. So you actually have a full dedicated service running for you. And while that's deploying, I'm going to go ahead and click edit service and kind of show you guys what else you can play with. So under the advanced settings, you can actually change the amount of data that you're storing if you want to increase or decrease the memory usage. And then you have dedicated amount of CPU, and then also a cost optimization toggle, which uses this thing called spot instances on Amazon or preemptible nodes on Google. And then at the bottom right, you'll also see the max monthly cost. And this cost is the worst cost that you can have throughout the entire month. Our billing model is pay per second. We actually allow you to deploy 3 free services on our free tier. So you can have Hasura, your front end app, and a database running on KintoHub for free. And then after that, you can put in your credit card and you can have a database running for $250 a month. So I'll go and discard that now that we have a live version running. So here you'll see in the overview, you have your usage. You can see how much memory and CPU your database is using. You have your release history so that you can roll back if you do any changes. You have your console so that you can actually see the real-time console logs. You can actually set up high availability with it, so you can drill down into multiple instances of Postgres. You have an access tab. So I'm actually going to copy and paste the connection string for the next step of setting up Hasura. And just nice little place to see what's going on. And then you have your settings where you can suspend your database, which will just pause it from charging you and go offline, and you can also delete it. So now that we have a database set up, next thing we want to do is deploy Hasura next to it. So I'm going to create a service, and this time I'm going to create a web app. But before I do that, I'll kind of just show you what else we have. We do static websites, which are always free. So if you have like a Gatsby website, or you're just statically building your files with like a React build for production, that can run there. Web apps are services that are running with a port. So Hasura is a good one, a good example for that. Or if you're doing server-side rendering, a backend API could be used for like manual GraphQL or HTTP, TCP, whatever backend APIs you're interested in creating raw scratch. Backend workers are good for like consuming messages on Kafka or RabbitMQ or Redis, etc. And then jobs similar to Hasura's cron job system, except ours will just run your code whenever you schedule it. So I'm going to create a web app. I'm going to choose the Hasura template. Here it's a Docker file, which runs on port 8080. I need to set up the environment variables. So we got the Hasura GraphQL database URL, and I'll paste that connection string that I did. And then we have Hasura GraphQL. I think it's enable console. We want to set that to true. Okay, so it looks good. And then I'm going to hit deploy. So here it's going to start pulling the code from the repository that I set up earlier. It's going to start building the image. I'm guessing it's going to use a cached image, since I use this environment a lot to show off Hasura to other clients. And then after the building step goes, it's going to go to the deploy step. And we find this pretty special because instead of having to go somewhere else to see what is happening on your logs after you deploy, everything is happening all in one spot. So you have your builds. If there's any build errors or anything going on here, you would see it. And then you have your actual logs running for Hasura. It actually looks like there might be an issue. Let's see. Yeah, or it'll take a minute to connect. Yep. So now it's gonna show a bunch of cool green stuff and keep moving forward. So now that it's deployed, yeah, there's definitely an issue. Let me see if I can fix it quickly. So for some reason it's live. Let's see if I did the environment variable raw. Yeah, it's good. Yeah, it all looks fine. Let me just check out the connection string real quick. Let's just try that one more time. And I'll just change the settings to increase the deploy timeout. And I'll just give it some dedicated CPU just in case. We'll give it another shot. I guess while this is building, what I'll also show you real quick is just our CLI. So we do have CLI tools to connect to your database. All of our databases are privately, and there's no public endpoint. So it's actually not compatible with the Hasura cloud yet. So similar to Git, if we go to Git status, it's all referred to what Git repository you're working in. So in my KintoHub folder, I could do Kinto status to actually see where I've deployed this folder. And then you can see it's in 3 different environments on KintoHub. And then if I use a command called Kinto teleport, I can then choose which environment I want to access. And then it creates a tunnel, secure tunnel to actually access that database. So I can use port 5360 to access the database that's running on KintoHub. So just wanted to share that real quick in terms of actually modifying anything. And let's try this one more time. It worked. So yeah, here's Hasura running on KintoHub. It's connected to the Postgres database, and fortunately it worked. We do Let's Encrypt SSL certificates and anything and everything you can imagine you'd want with an open source version of Hasura. And that's about it. Thanks, guys.
Thank you so much, Joseph. That was an amazing demo. Finally, we have Shahidh to wrap up this month's community call with his quick demo on Datadog that we missed earlier. Over to you, Shahidh.
Thanks, Vish. I forgot to share my other window while demoing Datadog integration. Okay, so I hope I'm gonna share the right screen this time. Let's see. Okay, if you can see a Datadog screen, then it means it's the right screen.
Yep.
Okay, awesome. So this is a Datadog account configured to get updates from Hasura Cloud or metrics and logs from Hasura Cloud. So just switch to Livetail and went ahead and created some tables on the Hasura console. And after the tables are created, we just created one table, inserted some data into it. And what we're going to do is make some GraphQL queries on this Hasura instance. And this Hasura instance or this Hasura cloud account is configured to send this data into Datadog with the configuration that I've shown you earlier. And Datadog is going to display the events as they come in, and we might just have to refresh it here a bit. And yep, so once you configure that, each and every log line or a processed log line is going to come up on Datadog on the Datadog log tail. And this includes all information that you see on Hasura's metrics operations tab on Hasura console. And it also includes refined information like if it is an error or not, what's the execution time. So you can build your dashboards or alerting, or even other metrics can be derived from this. And you can also set up and set up collection of logs from other services, and then correlate it with using request ID and with traces and all. So this is a work in progress. It should be available very soon on Hasura Cloud. So watch out for the update on the Datadog integration. Thanks a lot. Sure. Yeah, that's it.
Awesome. Thank you so much, Shahid. I'd quickly like to wrap up with a community update section. Won't take much of your time. Let me share my screen. So we have a bunch of really cool upcoming events. The first one is Graphical Contributor Days 2020, and this time we're going free and virtual. The first event is on November 17th, 9 a.m. PT, and here are some of the exciting topics that our guest speakers will be talking about. What's new with GraphQL auth, security patterns, using GraphQL with microservices, etc. The goal of GraphQL Contributor Days is to not only provide a platform for the GraphQL community to connect with other GraphQL enthusiasts, but also have direct access to authors and core contributors of various libraries and frameworks through live chat and online broadcasting. Next up, we have a webinar that's coming up on Hasura database schema migrations on 17th November, again, 9 a.m. PT. And every Thursday, we host these office hours where the community can come hang out with the Hasura team and ask any questions that they might have. We do this every Thursday, 11 a.m. PT. So stay tuned for that. And we're always looking for improving our community calls. So please make sure that you leave any feedback that you might have for us through our feedback form. We'll be sending the links to you in a follow-up email. So make sure that you leave any feedback that you might have about how we can make the next call better. And if you would like to come present something cool that you're building with Hasura, like Joseph and Bostjan, then feel free to add those ideas to our community call demo form and let us know that you'd be interested to come join our next community call. Thank you so much, everyone.